All right, hello everybody. It is Mike. This is my hand, and this is the final assignment for grade 10 math. So this should be after the 30 question quiz, or depending on what year it is, this might be being used elsewhere. So this is the final assignment that rounds out a bunch of different pieces, including triangles, cos, tan, sine law, lines, quadratics, all the things that you need to know summarized into a nice little final assignment. So let's start at the beginning. So number one here are lines. Now, lines and graphing them specifically requires often t-charting and then getting an equation, going to a t-chart, and then graphing that on a coordinate plane. So let's go through that as an example, just so that everybody's clear here. So, for example, y equals mx plus b is the general form of a line. What that is y and x are the coordinate plane, and m and b are different values. So y and x never change. M and b change, and m here is the slope. Basically how up or down it is. And this is the y-intercept. So the y-intercept meaning where it hits on the y-axis. Now if that's new to you, there are other videos, there's other supporting videos. I put a link in the bottom, just below here, for the Khan Academy to go over these basics. So that should be familiar. So you might get something like y equals 2x plus 1, where this is the slope, this 2 is the m, and the 1 is the b. So let's take this as an example. We might do a t-chart. So in a t-chart, you write the x's and the y's, and you choose values of 0, 1, and 2, and then also -1 and -2. For x, and we're going to take each one of those values, we're going to put it in here for x, and then we're going to have a y value get spit out. So basically, as we do all the things to x, the value we're left with is y equals that. We're going to put that number here. So let's start with 0. 0 times 2. 0 times 2 is 0. Plus 1 is 1. So when x is 0, y is 1. Then we start with 1. So when x is 1, 1 times 2 is 2, plus 1 is 3. So you can see how we're going to do that for each one of these here. 2 times 2 is 4, plus 1 is 5. Now -1, that gets a little bit more challenging because we're dealing with negatives. So always watch out for the negative signs there. So -1 times 2 is -2. And -2 plus 1 is actually -1. So -2 going in the positive direction on the number line. 1, that gets us to -1. And then -2 turns this into -4. -4 plus 1. -4 plus 1 is -3. You'll also notice here that there's a pattern, right? -3, -1, +1, 3, 5. It would go up counting by 2s in this kind of way, where we're starting at 1 and counting in either direction from 2s. So those things, you might be creating those cross connections. If this is brand new to you, again, there's some support videos. So let's actually graph this thing. And again, on a whiteboard, I don't have great coordinate planes. So maybe I'll use a different marker here. But first things first, let's graph this. So 0 on the x. Keep in mind, this is the x, right? This is the y. 0 on the x, 1 on the y. So that might be there. Then 1 on the x and 3 on the y. So 1 on the x and 3 steps up is about here. 2 on the x and 5 on the y. So 1, 2, and 5 on the y is about here. You start to see this taking shape. And keep in mind, this here is the point 2, 5. That's 2, 5. We'd normally put that in brackets. And then if I graph the other two, they'll be like this. I can get the details. This line comes from this t-chart of values, which then comes from this equation here, which is all kind of from the theory of this slope and y-intercept thing. So that is lines in a nutshell. Now, let's go in a little bit more detail to the specific questions of the final assignment. So, you're going to see several lines. So, let's talk about that. So, several lines, same graph. Now, I might be given, let's draw a graph over here, and I'm just going to do some easy ones to demo. So y equals x, that is a line. Just to be clear, that is the line y equals 1x plus 0. See what I did there? See that this is just 1x and this is plus 0, but we don't actually need to write that, so we just write y equals x. So y equals x goes through this middle point here, and then it also goes 1 over and 1 step up, and it keeps going like that all the way up and all the way down, because when it takes 1 step to the left, it takes 1 step down, and then you can draw a line here. So that is the graph y equals x. What I'm asking you to do in that first question is graph 3 lines. So that might be our number 1. So if that's our number 1 line, I might draw 1 here to label that's where that is. Now, second of all, I might have another graph that's like y equals, let's say -2 plus, -2x plus 4. So if I graph that, I'm going 1 up, 2 up, 3 up, 4 up. But then, so that's where the intercept is. And then I'm going down 2. So I'm going to go 1, rise over run. So it's going to go up 2 and over 1. So this is going down over 1 and down 2, which is like here. Is that accurate? Actually, let's say if it's down 1, it's actually about here. And then there's another one. Ooh, this is hard without the grid system. So it's over 1 and down 2, and then it's over 1 and down 2. So this, and I could do a t-chart of that, and to just get it as accurate as possible, I should, because I'm kind of fiddling around in here, but this might be graph number 2, so I'm going to label that with 2. As you can see here, there's actually a point where these intersect, and I should draw little arrows on this because they go forever, so I can do that there. Now, there's a point here where those 2 lines meet. Just to switch up the color, it's right there. I could calculate that, and I'll do that in a second, but I want to put 1 or 2 more lines on here. So I'm going to do another line, which is, let's say, y equals, now let's say 3x plus 4. Now that's going to be our third line on here. So y equals 3x plus 4. Well, I know it's going to go through here, and I'll do a t-chart, and you folks should be doing a t-chart, right? You should be doing this, like I said in the earlier question. So you should be doing x and y, 0, 1, and 2 for values. We're going to calculate y, do a -1, -2. And so if I plug this in here, 0, 3 times 0 becomes 0, 0, and then 0 plus 4 is 4. So I got 4 here. When that's 1, this becomes 7. 1 times 3 plus 4 is 7. 2 times 3 is 6, plus 4 is 10. And then -1 is -1 times 3. So -1 times 3 there is -3 plus 4 is +1. So that becomes +1. And then -2 becomes -6, and that becomes -2 there. So we know that it's also going to go through here, -2, -2. and it's going to go through x equals minus 1 and plus 1 here, and I could graph the rest of those points, and when I do, I see that I'm going to get something that looks like this. And this is graph 3. So I've labeled these according to what I see here. And now, the important piece, and I can erase that t-chart, is looking at what we've created. So we've actually created a shape by boxing in all of that space. And it's hard to see here, but essentially the shape is a triangle, and it includes this region, and this region down here. You can see that there's like a red shape there. That is a triangle. And so that's important for the future, but we're also looking at intersection points. So here's how to calculate those. We can either, one, actually find those intersection points. I gave you some easy graphs here. And so if I look on my chart paper and it goes right through there, I know that the point -2 and 2, so -2, comma, -2, I'm sorry. So we're going -2 and -2 down, is this point, and that is the point of intersection, because I can see where these two lines meet. So that's line 3 and line 1 meet there. Now, what about up here? Where do line 2 and line 3 meet? Well, that's here. This is here. And so they meet up here, which is at the point 0, 4. Now I can see those two. That's relatively straightforward. But this one might be a little bit trickier. So that's line 1 and 2. And I'll give you a trick of how you can solve this anytime. And so we're going to look here at solving these. Now you'll notice 1 and 2, that's all we're dealing with. So I'm going to erase 3 for now. Remember that it's still on there, but we only care about this point of intersection between 1 and 2. So it has nothing to do with 3, so I'm going to get it out. So here's what I would do. If y equals x and y also equals -2x plus 4, if I want to find how these are connected when they're equal, when they both pass through the same place, notice that these are both y's. And I'm going to set these equal to each other. So I'm actually going to move that down and say, okay, y equals x, y equals that. Well, that means that x equals this. Wild. What did I just do? I took this side and made it equal to this side. And now if I do some algebra on this, let's say I have 1x here and I have 2x's here. I'm going to move 2x's across. So I'm going to add 2x here. That's going to cancel that out. That means I have to add 2x on this side. That's a big jump if you're not used to the algebra. So -2x is on this side. Move to the other side by adding 2x here. That cancels that out. We add the 2x. So now we're up to 3x here. And 3x equals what's left here, 4. So if I divide both sides by 3, I get x equals 4/3. So I know this point of intersection, the first part of that is when x equals 4/3. Now that's not a very nice point, right? And you could do that on your calculator, you're going to get like 1.33. So the x coordinate of that point is 1.33, let's say. Let's convert this fraction into a decimal. So 1.33. Now, but I still need the y. So if that's 1.33, then I take that and I plug x back in to whichever of these makes sense or is the easiest. So if I plugged it in here, if you actually did the math on that, you'd get the same number, 4/3. And why? Because x is also equal to y on that line. And so this is the same value. So the y value is 1.33 as well. This is a tricky question, but that's me getting the 3 points of this triangle of the intersections. Complex question, but hopefully helps clarify some things there. For the actual question, just to give you a quick hint, this is kind of what it looks like. And so you're going to have 1, 2, 3 lines with a shaded region in the middle. Now, we've also identified the 3 points, and the final piece, the optional bonus, and I'm not going to give too much away on this. You can search this up online. I'm just going to erase this stuff. And let's write here the area of a triangle. Area of triangle. So what's the area of a triangle? Well, notice that there's a larger square here. So if I zoomed in on this down to here, down to here, down to here, up to here and across, let's say this purple square. So I've got a big purple square here, and it's that purple square. You'll note that there's a triangle inside, and it goes down to there, and it goes over to here. It goes down to here. Do you see that triangle inside and that square outside? The way we're going to figure this out is we're actually going to take the area of the whole square, which is base times height. And in this, I could tell you it's 6 for the height, because it starts at -2 and it goes up to 4. And then for this direction, it starts at -2 and goes over to 1.33, so that's -2 plus 1.33, which is 3.33. So 3.33 times 6 is going to get us around 20. That's a rounded number, so please don't think that's exact. But it's close. And then 20 is the whole. Now we need to subtract this area. So let's call this A1. We need to subtract A2, and we need to subtract A3. So this is the bonus question. Obviously, this is tricky. So let's say if the whole area was 20, then we actually need to subtract each one of those. And to get the area of a triangle, you're going base times height divided by 2. So in this case, for example, actually that's maybe not the best case. Let's use A3. So A3 in this example is going to go up 6, so the height is 6. And this direction is going over to here, so that's 2. So the base of that triangle is 2. And we need to half that, so that's 12 divided by 2 equals 6. So the area in this example is 6 units for this triangle. You have to calculate using base times height divided by 2. This triangle, subtract them all from this total, and you get your total area. So that is the first set of line questions. And let's move on to the next. The next are very connected to the lines. They're quadratics. And so let's write that here, and we'll recenter a little bit. Quadratics. All right, so jumping back in. Let's start with things that we know. Y equals x squared. What's squared? If you need help with that, you need to look up exponents and squaring and do some research on that. That is assumed knowledge at this point, so you should really know what that is. So for example, 3 squared is 9, 10 squared is 100. If that's challenging for you, then you're going to have to look that up and make sure you understand. So y equals x squared. We can do a t-chart here. And so we've got x and y. Now, if x is 0, 1, or 2, -1, -2, that's always the values we choose. When x is 0, 0 squared is 0, y is 0. When x is 1, 1 squared is 1. When x is 2, 2 squared is 4. This is where some stuff starts happening. How about negative? Well, negative 1 squared. A negative times a negative is a positive. I want to write that out, it's so important. A negative times a negative is a positive. That is so important. A negative times a negative is a positive. And that's with squares. You need to understand that. For example, or another example, is a negative times a positive equals a negative. These are like fundamental. If that's also new, then you're going to have to look that up and review that because that's assumed knowledge in grade 10 here. So, negative 1 times negative 1 is positive 1. And negative 2 times negative 2 is positive 4. So as weird as that sounds, the negatives are still going positive. So let's actually graph this thing. And when you graph it, we've got the point 0, 0. We got the point 1, 1. We also got the point negative 1 and 1. We also got the point positive 2 and 4. We got the point negative 2 and 4. And you start to see the shape coming, and that is a parabola. That's what that's called. So this parabola is y equals x squared. And so we can graph all sorts of things. Let's leave y equals x squared on there and on the graph that we've got. And let's take a look at a different kind of question. So we got y equals 2x squared minus 4. So I'm not going to cheat on this because I know some of the things, but the tricks of the trade, because I've been doing this a little while. So we got y and x here. We're going to do 0, 1, 2, negative 1, negative 2. 0 in for x. 0 squared is 0 times 2 is 0, but then we've got minus 4 there. So when x is 0, y is minus 4. When x is 1, 1 squared is 1 times 2 is 2. And then minus 4. 2 minus 4 is minus 2. Now what about 2? 2 times 2 is 4. Now 4 times 2 is 8. 8 minus 4 is 4. You're starting to see this shape up. And I'll just let you know right now that if I plug in minus 1, that's positive 1. 1 times negative 1 times negative 1 is positive 1 times 2 is 2. 2 minus 4, negative 2. You'll see that it's in line or mirrored here. Negative 2 times negative 2 is positive 2, or positive 4. Positive 4 plus 2, or times 2 is 8. 8 minus 4 is 4. If we graph that on here, we're looking at starting at this point 0, negative 4, and then we're going to go up and over. We're going to go up and over. And then we're going to put the point 2 and 4, which is actually right here as well, and which is actually right here as well. So coincidentally, I just gave you something that was a bit more narrow. And you can see it kind of fits in there. It goes a little bit deeper. It goes down to minus 4. I can give a third example here. And another example might be y equals negative 2x squared minus 4. Let's do minus x minus 2. Actually, I want to do minus 6. So we've got this other graph, and that's just another example like the ones that you're seeing on your worksheet. So you should feel comfortable with this kind of thing. We do a t-chart here. We do x and y. We always do 0, 1, and 2. Negative 1, negative 2. Start with 0. Here's how we do this. 0 squared is 0. 0 times negative 2, that's 0. Minus, well that's 0, so that's all irrelevant, minus 6. So this is minus 6. And let's start graphing this right away, because we might actually see where this is. So that's minus 4, this is minus 6 here. So that's the first point that I have. Now let's throw 1 in there. 1 squared is 1. 1 times negative 2, well, that gets us negative 2. Now minus, x is 1, so minus 1 minus 6. So you see how I solved this first bit by squaring, then multiplying. Then I did this next term and then this next one. So negative 2 minus 1 minus 6, that's negative 9. So let's try the next one. When x is 2, 2 squared is 4. 4 times negative 2, well, that's negative 8. Minus 2 minus 6, so we got minus 16 there. How about negative 1? So let's put in negative 1. Well, that becomes positive 1. And then positive 1 times 2 times negative 2 is negative 2. Don't forget those negatives and positives. Now we put in negative 1 for here. Now negative 1 becomes positive 1. And that's tricky. Negative 1. Those two negatives cancel each other out and flip back to a positive. So we got negative 2 plus 1 minus 6. Negative 2 plus 1 minus 6 is minus 7. Then we'll do this last one, negative 2. So negative 2 squared is positive 4. Positive 4 times negative 2 is negative 8. Then negative 2 is plus 2, and then minus 6. So we've got negative 8 minus 6 is negative 14. This is negative 12. So we got a lot of negative numbers on here. And when we really start to identify this, we got 0 and 6, we got 1 and negative 9. Let's say here. We got negative 1 and negative 7, which is, let's say, here. And then we got 2 and negative 16, which is way down here. We got negative 2 and negative 12, which is like here. So you start to actually see something, and if I'm going to draw this, it's going to be something that looks like that. Now, that nuance of it's not actually the peak is a bit tricky, but this is how we start to do that when we plot this out. So we've got a bunch of different quadratics, we've got a bunch of different shapes that are hanging out all over on the coordinate plane. That is the quadratic question there. Now, otherwise, we also have things on here that say, what about these numbers? So, for example, what does this do? Because we've got y equals ax squared plus bx plus c. Now, when you think about this, that a being negative, flipped it upside down, right? This is the only one that opens, it looks like a mountain, whereas the other ones face up. So the positive value out front means that it points up, the negative value points down. Also, a, as it goes up, it gets skinnier. So the value here of 2 gets really skinny. This is also skinnier than the one where it was just a value of 1. So that's what A actually does. B, we don't know enough math at this point to go into B, so we kind of skip over that. It's a little bit more complicated. But then there's C. And you should have noticed by now that C, that last digit, is where the y-axis hits. So for example, this is negative 6, this is negative 4, and this is right at 0. So C, that last value here, in this case it's plus 0, shows where it intersects on the y-axis. And that is what you can write for those answers. In terms of solving for these, where they touch, the bonus question, it's the same as the lines, but you need to trust yourself. I'm going to erase these first bits here. And I'm just going to look at these two. So these two graphs touch, and the place that they touch, the values, set y equal to another, and we got x squared equals 2x squared minus 4. I'm just going to pause here to pull the curtain. right, coming back to this. So we've set this equal to this because they both equal y, and we want to see where they're connected. And this is like the trick. So when x squared equals 2x squared minus 4, well, if I solve this and I subtract 2x squared here to cancel that out, I have to subtract 2x squared here. 1x squared minus 2x squared actually leads to negative x squared equals negative 4. So that was a bit of math there, but I'm taking this and basically moving it over to the other side. And 1 minus 2 is minus 1. X squared equals minus 4. X squared equals 4. X equals 2. Or, if you want to be fancy, minus 2. Now, you got to wrap your head around that. I've chatted with you likely about this. If you're seeing that and you're like, that blows my brain, don't worry about it. But if you want to think about this, negative 2 squared also equals 4. 2 squared also equals 4. What? There's two options? Yeah, there's 1 point here and there's 1 point there. That gave us both of those points where they met up. Wild! That's the magic of math right there. I know you're as impressed as I am. Let's keep going. So, let's go on to triangles. Now, triangles in trigonometry, these are important for grade 10. So, triangles and trig. So for triangles and trig, triangle, any three-sided shape. This might be a right-angled triangle. This is a random triangle. You can categorize all sorts of different weird-looking triangles. We're not too worried about that. There's vocabulary. You can look it up. What we are worried about is how to handle triangles, especially in this right-angled situation. So there's this thing called Pythagoras. Basically, this guy a long time ago was looking at triangles and was thinking like, okay, well, if there's a right angle here, that means a 90-degree angle. And let's say if this is 5, this is 3, and this is 4, what ends up happening is that these always follow a similar situation where a squared plus b squared equals c squared. What do I mean by that? I mean that the hypotenuse, the weird thing, the weird longest side across from the right angle, that's always c, okay? That's really important that this is c. So if I draw like a triangle like this, and that's a right angle, this is c, because it's across from the right angle. So we got c is 5. So let's say 5 squared. And if this is true, then 5 squared should equal 4 squared plus 3 squared. Well, let's take a look at that. So 3 squared is 9 plus 16. Does 25? Yeah, 9 plus 16 is 25. Totally, that's true. Okay, so all of this is still true, and it showed us that 25 is the square of this. So let's actually use this formula in a real question, because you need to have a question. So let's say in a triangle, I have something like, and I'm probably going to have to draw these dimensions a little bit differently. I'm going to draw it skinnier. So I got a right triangle here. I know it's right. This is going to be 90 degrees. I'm going to say this is 21. No, I'm not. I'm going to say that this is 2 and this is 8. What is this side length? How the heck do I find that out? Well, I take a squared plus b squared, and that's going to equal c squared. Okay, so in that case, this is c. So a squared, I can actually pick either of these for a and b. That's an interesting thing just based on perception. So let's just pick 2 for a. 2 squared plus 8 squared should be c squared. So this is 4. 8 squared is 64. And that's going to be c squared. So 4 plus 64 is 68. Now that equals c squared. That doesn't equal c. C does not equal 68. That makes no sense in this diagram. We need to take what's called the square root of 68, because when we take the square root of c squared, it becomes just c. So when we take the square root of 68, you can do that on your calculator. You can punch in and find either this symbol or there's other ways to do it. You can ask me in class, or we can talk about that more. So in this case, c is also root 68. That's how I solve this and look for an extra side length. So that is the Pythagorean theorem, and hopefully that explains what we're doing there. Now, a crash course on sine, cos, and tan, sine x, or sine of an angle. Let's actually do it. Toa. You might hear of that. We're not specifically going to address that, but sine is 30 degrees. Sine of, or let's do cos. Actually, and I'm going to change this to 60. Sine of 60, cos of 60 degrees, and tan of 60 degrees. What the heck am I talking about? These are on your calculator, so let me bust out my calculator. Just getting it out here. Now, I have an Android. That's what it looks like. That's what my calculator looks like. However, if I push this button, it expands. Now, you might sometimes need to make it go sideways, and you'll notice that it might not come through, and it doesn't really come through. That's fine. But there is a button for sine, cos, and tan. And you want to just get a sense of your calculator. So let's say I hit the sine button and it comes out with that. Some calculators, you have to put the number in first, then hit sine. Some of them, like this one, I have to hit sine and then the number. So the sine is 60. So let's hit sine of 60 equals. And as weird as that sounds, that's the number that I'm looking for, 0.87. So let's round. Now, cos of 60, let's clear that up. In my calculator, I'm going to hit cos 60 equals, and I get an answer of 0.5. That one's simpler. Now, tan of 60, let me hit tan, the button tan, and I'm going to put in 60 here, and I get a number that's 1.73. Now, you don't have context on this yet. We might have gone over it a little bit in class. But I need to make sure that you know how to do this and that these are related to triangles and the angle. You can only take sine of an angle or cos of an angle or tan of an angle. You can't take tan of some random number. That's not how it works. Now, the other flip side to that is doing arc or inverse sine, cos, and tan. So you might see it as sine to the negative 1, cos to the negative 1, or tan to the negative 1. You might also see it as a tan, or a cos, or a sine. These are the same thing, okay? You don't have to write this down, you just have to know. So whatever you're seeing on my calculator, for example, and it's hard to tell, but if I hit second, I hit the second button, then it comes up as sine squared, or sorry, sine to the negative 1, cos to the negative 1, tan to the negative 1. So I'm going to use these to actually calculate the angle. So it's normally set up as, let's say, sine of x equals 0.25. Well, sine of x equals 0.25, then I need to clear, and I have to hit that second button on my calculator, second sine, and I put in 0.25. I put in what's on the opposite side, and I get an angle So when I sine -1 of 0.25, I get 14.5 here. Now, that is the number that I'm looking for, so essentially x equals 14.5. Now that is the same, that second function works for cos, works also for tan. So if it was, for example, tan of x equals 0.25, then I would have to hit second tan. So I hit tan, no, I'll clear that. I hit second tan to make sure it's a tan or tan to the -1 of 0.25. And I get a different answer, which is actually just slightly different, which is 14.03. 14.03. So that changes, and the arctan, the second tan, the second sine, the second cos is used to find the angle. And so that should be enough information to help you out with those questions there. You also, in these questions, only want to round to the second decimal place. Don't go longer than that. Some of these numbers are hideously long. And let's move on. We're getting there. We're almost at the end. So the last two things. Sine law. So, sine law. This is a law that basically says in a triangle, I've got three angles. I've got C, I've got angle B, I've got angle A. Then this is side A, side B, and side C. So sometimes we need to talk about angles, sometimes we need to talk about sides. We're going to do that in a corresponding way. So angle C is across from side C. Side A is across from angle A. Angle B is across from side B. It's all kind of connected here, right? Angle B, side B. Now, sine law says sine of whatever angle, let's say C, over side C, and this is a length. So this would be like on your calculator, right? We just did that, sine of C. You push sine of whatever value this is, not this. You'd want the angle, sine of the angle here. Over the length, so this is the side length. That's going to equal, that ratio, sine of C over C, is going to equal sine of A, angle A, over side length A. Or it's also equal to sine of B over side B. Weird. It's a weird fact. It's just like these things are true. When you do all this stuff with sine, they just equal each other. So let's go into a question here and see what that looks like. So I might have this kind of triangle, but I might have it set up so that, for example, this is a side length of 4, and this is 80 degrees, and this is only 30 degrees. That's a terrible 30. Let's make this 30. Let's make that clear. That's 80. And I don't know what this side length is. So I have two angles and a side. I want to know what side length is. Boom, we use sine law. So sine of 30 divided by the corresponding length, which is 4, equals sine of 80 divided by x. And this is just some algebra. I happen to know that sine of 30 is 0.5, so I can do that on my calculator. So 0.5 divided by 4, well, that's also equal to, no, it's not. It's, let me just double check it here. 0.5 divided by 4 equals 1.25. That's my bad, I did it in the wrong direction. 0.125. And that's still equal to sine of 80 over x. This is equal to sine of 80 over x. And this gets into some algebra, and so just to be clear on how to do this, you can essentially switch these two numbers or multiply each side by x. So if you multiply this side by x, the x's cancel. We've got x here, and then you divide both sides by 0.125. So I can move that x up here, and then I essentially can move and divide both sides by that. So I can move that 0.125 down here. So x equals that. You do that on your calculator, and I'll just show it quick here. So we got sine of 80. I'm going to do that first. 0.9848, and I'm going to divide 0.125. Bingo, I know side length is 7.88. So I know that this side length is 7.88. That's how I do that. In the algebra at the end is a little bit challenging, but when you've got the x on the bottom and you need to find it, that's an extremely essential skill for algebra. And if this isn't clear, then you need to check out more videos and practice your algebra. Let's do another one here. I'm going to leave that one triangle out, and we're going to talk about cos law. Let's do this in purple. Cos law. Okay, this gets a little bit more challenging. Essentially, here's the formula. C squared equals a squared plus b squared minus 2ab cos c. Now, I ran out of room there because I got too ambitious. So that's minus 2ab cos c. What do I mean? Angle C and side C are connected. You need to connect these. First things first in any question, you need to see what C is, and you need to see the angle. So, in the case where I give you a question, and the question looks like there are 3 sides. I got 3, 4, and let's do 5. No, let's do 6. 3, 4, and 6. In the case of 3, 4, and 6, I'm going to look for this angle. So this is my C, okay? That means this is the corresponding angle and needs to be there, or the corresponding side. So that would need to be 6. 6 squared equals, and let's choose 3 and 4 randomly, so it doesn't matter which one of them goes into A or B. So we got 3 squared plus 4 squared. Okay, a squared and b squared, that lines up, that checks out. What about this 2ab cos c? So we got minus 2 times a, which is 3, times 4, which is b, times cos of c. That's what we're looking for. So we can start to actually solve these. So that's 36, this is 9, this is 16, minus 2 times 3 times 4, well that's 6, times 4 is 24, cos c. Okay, well this gets more manageable now. So 9 plus 16, well that's 25. So if I take away 25 on this side, I got to take away 25 here, so I'm left with 11. So 11, and I've already dealt with this stuff, equals minus 24 cos c. So what do I have to do now? Well, I divide by 24. So I divide both sides by 24. That cancels that out, and I got negative 24 here. So negative 11 over 24 equals cos c. And I'm going to come back up here. And don't forget this triangle with this applying. But let's just do a little bit more algebra just to kind of close it out. And I'll switch it around. Cos c equals negative 11 over 24. That's where I can do that on my calculator. and I can clear that out. And I've got, so I've got, let's do 11 divided by 24. Then I'm going to hit the plus minus button to make sure that's minus. So, and actually I'm going to write that number down just because of the order of things here. So this is negative 0.4583. And I'm going to do inverse cos. So that's the second cos. And why? Because I'm trying to find what this angle is. And in order to find an angle, I got to do inverse cos. So inverse cos, or a cos, of this number. So we've got negative 0.4583, close bracket, 117. So the number that spit out, and the angle C is the angle 117 degrees. Now that was a lot. This is a specific and dense formula. I'm going to be impressed if you can get it, but it is an important thing to touch on, and the algebra is heavy inside of it, but if you're looking for that angle, that's how you do it. You plug in all the values, and please make sure that that C side is corresponding with that C angle when you set this up. All right, that's about it. Thank you so much, and good luck with the assignment.